Okay, question 9, merge sort. Given an array of integers, sort the elements in the array in ascending order. The merge sort algorithm should be used to solve this problem. So the function is merge sort, and the input data is an int array that is not sorted, and the output is also an int array, and that is sorted. So the assumption here is to sort this array in ascending order. And possible corner case is when the array is null or the length is like 1 or less than 1. Then we can just return the array. And so the solution here is to use the merge sort. So the idea of merge sort is basically divide array into two parts, and then after we divide, and we continue to divide the left part and right part until it reaches a point where there's only one element on the array. Then we start to merge them, and when we merge them, we compare the value of the elements on both array, and we set out the pointers, and then we compare the value of those elements on the pointers. And then if we find an element smaller, then we added that to the new array. And after we do that, we move the pointer to the next one. And we do the same process until we go through all the elements on both arrays. And then we have all the elements on the new array and also have all the elements sorted. And then we continue to the merge in pair until we merge all those divided arrays, and then we have the entire array merged and sorted, and then we return. Okay, now looking into the code. Here, first is the sanity check. So when the array is null or the length less or equal to 1, then we just return the array. Then we do this recursion call. So call merge sort and provide 3 input. One is array, and the other two are the indexes. So in the beginning is the range is 0 till the end of the array, and then we set up all the recursion rule under the merge sort method here. And the base case basically is that when the left equal to right, then we return the array left, because there's only one element on the array, then we can just return it. And then if there are more than one element on the array, then we find the mean index, and then we divide the array into the two parts. So the first part is from the left to the mean, and the second part is from the mean plus 1 to the right. So we will continue to divide the array into two parts until it reaches the base case. After you reach the base case, we will merge that, all the divided arrays. And then the way we merge them is that we create a new array, and then we set out the pointers for the left array, right array, and then also the result array. So, and then we compare the value of the elements on the pointers. And if an element is smaller, then we added this element to the new array, and then we move the pointers to the next one. And after we go through all the elements, then all the elements will be in the new array and sorted. So for example, if there are A elements on the array, so we divide them to 4, 4, and then 2, 2, and then 1, 1. And after you reach the base case 1, 1, then we start to merge like 1, 1, and then merge to 2, and then these two will merge with another 2, and then merge to 4, and then 4 combined with another 4, and at the end all the A elements on the array are sorted, and we return this array. And so the time complexity of this function is n log n, because we need to divide the array by 2 until it reach base case. So basically there are log n layers, and in each layer we need to go through all the elements in order to to sort them, to find a smaller element. So that's O n, and then log n layers. So overall it's n log n. And then the space complexity is O(n), because basically for all the layers, the reason why we have so many layers is because we always need to wait for the other part of the array to be sorted, and the time when we have the most array pending is the time when we're not waiting for the one element on the right to merge. And then at that time we have like a 1 and 2 and 4a, all these 1 2 4a array waiting for that one to be merged. So basically there are like a 2n of a data on the heap. And so overall the space complexity is O(n).